Greetings. My name is Leah Markley, and the purpose of this video is to explain how to solve this particular question that we were assigned in Teach 880E this summer. The question is, positive integers a and b are such that the graph of y equals ax plus 5 and y equals 3x plus b intersect the x-axis at the same point. What is the sum of all possible x-coordinates of these points of intersection? I learned a tough lesson on this question that, I really tell my students to focus on, and yet, we get comfortable in the math that we teach, and sometimes we don't practice what we preach. But, after first looking at this problem, originally I completely disregarded this first part of the question that we needed positive integers. And then as I reread the question, my brain focused on integers. And so initially, I was kind of looking at making my sliders such that right now you can see the zeros only cover the negative values on the x-axis, but originally I was making them cover the values on the right, and without realizing that they were integer values specifically for a and b, I was starting to realize that there were infinitely many solutions on the right hand side that would also correspond symmetrically to those on the left hand side. And so I was kind of having trouble wrapping my brain around the problem. Once I realized that we could only use positive integers, this problem became much simpler. So the way I solved this was kind of a combination of ways, but I wanted to first show you the approach that I started with to get my chart rolling. My goal for this video is to explain this chart that I created, but I didn't come up with the idea for a chart until I came up with my graph. And so on my graph, I'm going to actually use my Desmos one because I like that better. I just started picking the first positive a value that I could come up with. And forgive me, I was toying around with the other question there. So letting a equal 1, I realized that the slope here was going to be 1. And I could just slide this second equation so that it intersected with the other one, and I could hover over to find that intersection point. So then I started thinking, well, why don't we just make this really easy? Let's set a chart up instead of having to use my sliders and click on things. And again, about halfway through this chart, I realized that since this column was really using an algorithm, and so was this column, it would have been better to have completed this in Excel. But now that I'm through with the problem, I'm not going to go back through and redo that. So the way I set this up is I just kind of used the same strategy. I picked an a value starting at 1. And then I took that equation that we were given, and I let a equal 1 right here. I let y equal 0. And then I solved for the corresponding x value. And so what would happen there is, in that particular case, I got -5. So then I went to the second equation, which was this guy right here, and I just replaced the x with that value to obtain the b value. And my goal was to look for rows where the a and b values were both integers. And so, again, had I done this in Excel, it would have been really quick. I could have just programmed a formula and drug it down. Experience is our best teacher. So I really liked this strategy because I knew I kind of had a comfort zone when I hit this last row. Since we started with an a value of 1, and that was the smallest positive integer, I noticed that this column was trending smaller and smaller. And so I knew that I could stop once I got to a b value of 1 or slightly less than 1 if it didn't come up to be an integer solution. So that's pretty much it. I guess once I got the chart figured out, to actually finish answering the question, I just took each of these middle values that are highlighted, these would represent the zeros that would correspond to the A and B values on either side of it that generate that particular zero on the graph. And so the sum of those four values here was -8. And I also noticed that since 5 and 3 were relatively prime, we were only going to end up with 4 possible values. And had those not been relatively prime, we would have had a more exhaustive list. All right, thanks for watching.